Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of vectors as velocity. So let's start with the problem. So a woman walks at 4 km per hour down the corridor of a train that is traveling at 80 kilometers per hour on a straight track. So in part A, we have to find her resultant velocity in relation to the ground if she is walking in the same direction as the train. So let's start with part A. So as per the problem, the train is traveling on a straight track at 80 kilometers per hour. So we can draw a vector to show the velocity of the train. So let's assume this vector represents the velocity of the train. Now the woman is walking in the corridor of that train at 4 kilometers per hour. So the vector that represents the woman's velocity will be much smaller than that of the train. So let's assume this vector represents the woman's velocity. Now as per the problem, in part A we have to find the resultant velocity in relation to the ground if she is walking in the same direction as the train. Now in order to find the resultant velocity for these two velocities, we'll have to arrange these vectors in tip to tail arrangement. Now since both of them are walking in the same direction, so we can arrange these vectors in tip to tail arrangement as, so this is the velocity of the train and this vector represents the woman's velocity. Now we know the equation for the resultant velocity is, now in this case both with given velocities, the train and the woman, are in the same direction. So to calculate the resultant velocity, we just have to add these two vectors as a regular sum. So the resultant velocity will be represented by this longer vector here. So vector VR. So V1 represents the velocity of the train, which is, and the direction is to the right side, plus the velocity of the woman, and the direction is also to the right side. So we can just add these two vectors as a regular sum. So 80 plus 4 is 84. And the direction will be the same to the front or the right side. So this is the resultant velocity of the woman in relation to the ground. So this should be the final answer for part A. Now we can analyze part B. So if she walks in the opposite direction as the train, what is her resultant velocity? So in order to find the resultant velocity, we should arrange the vectors in tip to tail format. So the train is moving to the right. Now in this case, in part B, she's walking in the opposite direction as the train. So the velocity vector for the woman can be shown in tip to tail arrangement as like this. Now I'm not showing the vector on the vector for the velocity of the train, because then it'll get confusing to differentiate between the two vectors. So the resultant of these two vectors will be this vector, or we can use VR. So now we can write an equation. So vector R will be equal to, so vector V1, vector V2. Now vector V1 is 80 per hour to the right side. Now since the woman is heading towards the left, so that means we can write the vector as plus, and the direction is to the left. But we cannot add these two vectors because the direction of the vectors should be the same. So we should switch the sign of the 4 kilometer per hour to negative and change the direction to the right side, because in order to add vectors algebraically, the vectors should have the same direction. And now we can combine the vectors. So 80 minus 4 is 76, and the direction will be to the right side, or the forward direction. So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand that in order to find the resultant of vectors, we have to arrange the vectors in tip to tail arrangement and then find their resultant. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.